On the morning of the 30th of June, 1908, something exploded over a remote stretch of Siberian forest. We do not know exactly what it was. We know it released energy equivalent to somewhere between 10 and 15 megatons of TNT, roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. We know it flattened approximately 2,000 square kilometers of forest, around 80 million trees, knocked flat, pointing outward from a central point like the spokes of a wheel. We know the shockwave circled the Earth twice, detected by barometric instruments across the globe. We know that for several nights afterward, the skies over Europe glowed so brightly that people in London could read newspapers at midnight without artificial light. And we know that for nearly 20 years after it happened, the wider world paid almost no attention. No crater was ever found. No meteorite fragments were recovered from the site for decades. No satellite was overhead to photograph it. The region was so remote, deep in the Siberian taiga, more than 1,000 kilometers from the nearest large city, that the closest eyewitnesses were nomadic Evenki reindeer herders, whose accounts were not systematically collected for years. The Tunguska event is the largest impact event in recorded human history, and it is in many ways still a mystery. Not because we have no answers. We do, and we will get to them, but because the answers we have came slowly, painfully, against extraordinary obstacles across more than a century of investigation, and because even now the details are still being debated. This is the story of what happened over Siberia on that June morning, and it is also the story of how long it took anyone to seriously try to find out. Let's go back to that morning. It is just after 7 o'clock local time. The sun has been up for hours. This is Siberia in midsummer. This far north, the nights are short. The Evenki people who live and work in the taiga around the Podkamennaya Tunguska River are going about their day. Some are in their tents, some are tending reindeer. A trading post at Vanavara, roughly 65 kilometers south of what will become the epicenter, is beginning its morning. At 7:17 in the morning, a column of bluish light appeared in the sky. Witnesses described it as brighter than the sun. It moved across the sky from the south-southeast, trailing a column of fire behind it. There was no sound yet. Sound travels slower than light, and this thing was moving fast. Then the explosion. Witnesses at Vanavara described being thrown off their feet. Windows shattered. One trader, sitting on the steps of his trading post, was reportedly knocked from his seat and briefly lost consciousness. When he looked up, the northern sky was split by what he described as a pillar of fire, a vast churning column of smoke and flame rising from the horizon. Further away, the effects were still dramatic. A man ploughing a field roughly 60 kilometers away was thrown into the air by the shockwave. Passengers aboard the Trans-Siberian Railway, hundreds of kilometers distant, felt the carriages rock. Seismographic stations across Russia and Europe registered a tremor. Barometers in England twitched. Closer to the epicenter, the scale of destruction was total. The Evenki who lived and worked near the explosion site fled in terror, abandoning their tents and reindeer herds. For some of the people closest to the event, the experience was religious, a visitation, a punishment, something beyond ordinary natural explanation. Some would not return to the area for years. The forest, in an area roughly the size of Greater London, had been instantly, catastrophically flattened. And then, nothing. No follow-up. No investigation. No scientist rushing to the scene. The world in 1908 simply moved on. This is the part of the Tunguska story that is almost as extraordinary as the explosion itself. For nearly 2 decades after the event, no scientific expedition reached the site. No one from the wider scientific establishment went to look. Why? Part of the answer is geography. The Podkamennaya Tunguska River region is extraordinarily remote. In 1908, reaching it required a journey of many weeks, by rail to the edge of the rail network, then by riverboat, then overland, through dense, difficult taiga with no roads, no infrastructure, and no reliable maps. It was not a place you went to casually. It was not a place most people had any reason to go to at all. Part of the answer is timing. The world in 1908 was not a quiet place. Within a few years of the Tunguska event, the political situation in Europe was deteriorating rapidly. By 1914, the First World War had begun, consuming the resources and attention of governments and scientific institutions across the continent. By the time the war ended in 1918, Russia was in the middle of its own revolution and subsequent civil war. The country that had experienced the Tunguska event in its territory was barely functioning as a state, let alone conducting remote scientific expeditions. Part of the answer is uncertainty. The initial reports that filtered out from Siberia were confused and contradictory. Nobody quite knew what had happened. The accounts spoke of fire in the sky, of tremendous explosions, of trees knocked flat, but without a crater, without a visible meteorite, without physical evidence of the conventional kind. It was not obvious what there was to investigate. In the early 20th century, the scientific framework for understanding such an event was not well developed, and part of the answer is simply that the event happened to the wrong people in the wrong place. The Evenki who witnessed it most closely had no connection to scientific institutions. Their accounts existed, but nobody was collecting them systematically. The region had no permanent population of any significant size, no local newspaper, no telegraph office close enough to file immediate reports. The event produced eyewitness accounts, but those accounts were scattered, informal and largely ignored, so the forest lay flattened, the mystery unsolved, for 19 years. The person who finally went to find out what had happened was a Russian mineralogist named Leonid Kulik. Kulik first encountered accounts of the Tunguska event in 1921 while working for the Soviet Meteorite Commission, a body set up to catalogue meteorite falls across the vast territory of the new Soviet state. He came across a reference to the 1908 event in an old newspaper and became convinced that whatever had happened represented the largest meteorite fall in recorded history, and that the meteorite itself, or fragments of it, must be recoverable. He was, in many ways, exactly the right person for this mission. He was methodical, determined, and apparently impervious to physical hardship. He was also, by this point, working within the Soviet scientific establishment, which gave him the institutional backing, however modest, to mount expeditions to remote locations. It took him several years to secure funding and permission, but in 1927, 19 years after the explosion, Leonid Kulik finally reached the Tunguska region. What he found there was extraordinary and deeply puzzling. The scale of the fallen forest exceeded anything he had been prepared for. Trees were knocked flat across an enormous area, all pointing away from a central region. Kulik's first thought was that this was exactly what you would expect around the impact crater of a large meteorite, the shockwave of impact radiating outward, flattening everything in its path. But at the center, where the crater should have been, there was no crater. Instead, Kulik found an area where the trees were still standing. Not intact, they were stripped of their branches, reduced to bare, scorched poles. But they were vertical. They had not been knocked over. They were directly beneath the point of explosion. This was the first physical confirmation of something that would take decades to fully understand. The Tunguska object had not hit the ground. It had exploded in the air. Kulik returned to the Tunguska region 3 more times, in 1928, 1929 and 1939. Each time he searched for fragments of the meteorite he was convinced had caused the explosion. He found none. He conducted drilling operations in marshy ground, convinced that the meteorite lay buried below the surface. The drills found nothing of significance. He died in 1942 in a German prisoner of war camp, having spent much of his adult life chasing a mystery he never fully solved. While Kulik was searching the forest, he and later researchers were also collecting eyewitness testimony from the Evenki and from Russian settlers in the region. These accounts, gathered decades after the event, are fragmentary and sometimes contradictory, but they paint a vivid picture of what those closest to the explosion experienced. S.B. Semenov, a witness at Vanavara, gave what became one of the most quoted accounts. He described sitting on the steps of the trading post when suddenly the sky split in two and fire appeared. The heat was so intense that he felt his shirt was on fire, and then the shockwave hit, knocking him from his feet and throwing him several meters. When he recovered and looked north, he saw a great fireball hanging where the explosion had been. He could not look directly at it for the brightness. Evenki herders, whose camps were within the immediate area, described the experience in terms that reflected their cosmology and beliefs. Some described a god of thunder or a spirit of fire. One account described the reindeer being scattered and the ground shaking. Another described the herder being thrown from his bed into the air. The language is not scientific, but the physical descriptions, heat, light, shockwave, the sound that followed, are consistent across accounts from people who had no way of coordinating their stories. One of the most striking details that emerges from the eyewitness testimony is the sequence of sensations. First, the light, the brilliant column crossing the sky, visible hundreds of kilometers away. Then, for those close enough, the heat. Then, with a delay that varied with distance, the sound and the shockwave. The timeline confirms a supersonic object moving through the atmosphere and exploding with enormous energy at altitude. What is particularly remarkable about the eyewitness accounts is how little initial attention they attracted. These were people on the geographic and social margins of Russian society. Their testimony was not systematically collected until Kulik's expeditions in the late 1920s, by which point the witnesses were recalling events from 20 years earlier, with all the problems of memory and reconstruction that implies. The Tunguska event left an enormous physical scar on the landscape, but it left almost no mark on the written historical record of its time. In the absence of physical evidence, and with the mystery unsolved, Tunguska attracted theories, many theories, some scientific, some considerably less so. The most straightforward early hypothesis, and the one Kulik championed, was that a large meteorite had impacted the ground, with the absence of a crater explained by burial deep in the marsh. This remained the dominant scientific hypothesis for decades, though repeated searches failed to find the buried object. When the nuclear age arrived in the 1940s, a new and alarming theory emerged. The energy released by the Tunguska explosion was broadly comparable to a nuclear weapon. Some researchers, and a great many writers of sensational articles, proposed that Tunguska had been a nuclear explosion. Not a natural one, but a deliberate one. An alien spacecraft powered by nuclear energy had crashed or been destroyed over Siberia. This theory found an audience. The Soviet period produced a remarkable number of books and articles proposing extraterrestrial explanations for Tunguska. Some suggested the spacecraft had deliberately steered itself away from populated areas, choosing the Siberian wilderness as the least harmful impact zone. Others proposed that the lack of a crater was evidence of a controlled descent that went wrong. These theories were entertaining, but not taken seriously by mainstream scientists who had no evidence for any of them and considerable evidence for a purely natural event. More scientifically interesting was the debate over what kind of natural object had caused the explosion. Was it a meteorite? A rocky body? A comet, primarily composed of ice and dust? Or something else? The comet hypothesis had a certain elegance. A comet moving at high velocity would interact violently with the atmosphere. The icy nucleus would ablate, vaporize, as it descended, releasing enormous energy in an airburst. The lack of surface fragments would be explained by the fact that most of the object had simply ceased to exist. The comet hypothesis was taken seriously by many researchers for decades. But it too had problems. Comets leave behind certain chemical signatures. The soil and peat at Tunguska was analysed repeatedly, looking for the elevated levels of certain elements. Iridium, for example, that are characteristic of cometary material. The results were ambiguous enough to keep the debate alive. In the decades following the event, Tunguska accumulated a mythology almost as large as the explosion itself, a testament to what happens when a genuinely extraordinary event occurs in a place where it can barely be observed, investigated, or explained. So, what actually happened over Tunguska on the morning of June 30th, 1908? The current scientific consensus, built up over more than a century of investigation and substantially strengthened in the last 2 decades by improved computational models and by a second, better studied airburst event in 2013, is that the Tunguska event was caused by a stony asteroid, somewhere between 50 and 80 meters in diameter, which entered the Earth's atmosphere at high velocity and exploded in an airburst at an altitude of roughly 5 to 10 kilometers above the surface. The object never reached the ground. The pressure and heat generated by its passage through the atmosphere caused it to fragment and then explosively disintegrate, releasing its kinetic energy not at a single point of ground impact, but in a rapidly expanding shockwave above the surface. This explains everything. The absence of a crater. There was no solid impact. The absence of significant meteorite fragments. The object was largely vaporized in the explosion, with any remaining fragments too small and too scattered to easily identify. The pattern of fallen trees pointing outward from a central region below the airburst. The standing but scorched trees directly beneath the explosion, where the downward blast stripped branches but did not knock the trunks over. The enormous energy release spread across a wide area rather than concentrated at a single point. The specific event that validated and refined this model came on February 15th, 2013, over the Russian city of Chelyabinsk. A small asteroid, estimated at around 20 meters in diameter, significantly smaller than the Tunguska object, entered the atmosphere and exploded in an airburst over a populated area. The explosion released energy equivalent to roughly 30 times the Hiroshima bomb. It shattered windows across the city. Over 1,500 people were injured, most by flying glass. It was captured on dozens of dashboard cameras and security cameras, studied in real time by scientists around the world, and produced a detailed understanding of airburst dynamics that directly informed reanalysis of the Tunguska event. The Chelyabinsk event was, in a profound sense, Tunguska's scientific gift to the modern world. It happened over a city in an age of cameras and sensors and rapid scientific communication. It showed us what a much smaller airburst looks like and allowed scientists to calibrate their models of what a larger one, like Tunguska, must have produced. The stony asteroid conclusion is now widely accepted. But it is worth being precise. No fragment of the Tunguska object has been definitively identified and recovered. The conclusion rests on physical evidence, computer modeling, and comparison with other events, not on holding a piece of the rock in our hands. The mystery, in that narrow technical sense, is not completely closed. Here is where the Tunguska story stops being historical curiosity and becomes something more urgent. An asteroid 50 to 80 meters in diameter. Not enormous by cosmic standards. Not the kind of object that dominates planetary defense discussions, which tend to focus on the city killer and civilization ender scale objects. Hundreds of meters to kilometers in diameter. Just a modest, rocky body, the kind that exists in the millions in the asteroid belt and in Earth-crossing orbits throughout the solar system. And it flattened an area the size of a major metropolitan region. Had the Tunguska object arrived 4 hours and 47 minutes later in its orbit, the time it takes for the Earth to rotate enough to bring the city of St. Petersburg directly below the trajectory. It would have exploded over one of the largest cities in Europe. The death toll would have been catastrophic. That is not speculation. That is orbital mechanics applied to a real event. Objects of the Tunguska size, 50 to 100 meters, are thought to enter the Earth's atmosphere on a timescale of somewhere between 500 and 1,000 years on average. We have detected and tracked the vast majority of the large objects, the truly civilization-threatening ones, kilometers in diameter. The smaller ones, the Tunguska-scale objects, are far more numerous and far harder to detect. We have catalogued only a fraction of them. The 2013 Chelyabinsk asteroid was not detected before it hit. It came out of the direction of the Sun, where ground-based telescopes cannot look. An object 20 meters in diameter arrived without warning over a major Russian city, and we only knew about it from the videos people took on their phones. The Tunguska event, rediscovered and slowly understood over more than a century, has become one of the primary arguments for serious investment in planetary defense. The detection, tracking, and, if necessary, the deflection of near-Earth objects before they can do what happened over Siberia in 1908 to a place with a lot more people in it. In 2022, NASA's DART mission deliberately impacted an asteroid called Dimorphos, not because it was on a collision course with Earth, but as a proof of concept. The kinetic impactor successfully changed the asteroid's orbit. We can, if we see something coming early enough, move it. The question is whether we will see it coming. On the morning of the 30th of June, 1908, a rock the size of a large building fell out of the sky over Siberia and exploded with the force of 1,000 Hiroshimas. It knocked down 80 million trees. It circled the Earth with its shockwave twice. It lit up the European sky for nights afterward. And the world, for nearly 20 years, barely noticed. That is not quite a story about cosmic indifference. It is a story about human geography and about how much of the planet is genuinely empty, and about what happens when the most extraordinary event in a century occurs, in a place where almost nobody lives and nobody with scientific resources can easily reach. It is also a story about how science works, about Leonid Kulik, spending decades pursuing a mystery in remote Siberian forests, dying before he found what he was looking for, about researchers who collected eyewitness testimony from people nobody had thought to ask, about the slow, methodical accumulation of evidence from soil samples and tree ring patterns and seismic records and computer models across more than 100 years, until a picture emerged that was consistent and convincing, even without a fragment of the object itself. And it is a story that is not quite finished. The Tunguska object has not been identified in our catalogues. We did not see it coming. We would not see a similar object coming today unless we were lucky or well prepared, and our preparation, currently, has gaps. Somewhere out there, in the dark between the planets, there are other rocks. Most of them will miss us. Most of them will drift through the inner solar system for millions of years without touching anything. But not all of them. The morning of the 30th of June, 1908, was a reminder of something the universe does not often bother to deliver gently. We live in a shooting gallery. We just happen to have been lucky so far.